Assalamu alaikum. Welcome to the third session of Chapter 12 Standard Functions. The objectives of this session are set up the table of variations of the affine function and the standard functions and representing graphically the affine function and the standard functions. Please prepare the following materials and let's start. Affine function. A function f is called affine if there exists two real numbers a and b such that f of x is equal to ax plus b. So the domain of definition of this affine function is R, and it's represented graphically by a straight line D whose equation is y equal ax plus b. So the affine function is represented by a straight line. B is called the y-intercept. It represents the intersection of D and the y-axis. So the point of coordinates 0b belongs to D, and A is called the slope. The line D intersects the x-axis at the point minus b over a, 0, where a is different from 0. Example 1. Which one of the following curves in figures 1, 2, and 3 represents an affine function? In fact, we remember that the affine function is represented by a straight line. So here we have to look which figure contains a curve that represents a straight line. In this case, it's not a straight line. In this case also, it's not a straight line, but in figure 3, the curve represents an affine function since it's a straight line. Application 1. Find the affine function f whose representing line D passes through the point a1, 2 and its director coefficient is minus 1. Please stop the video and try to solve the application. In fact, you know from previous chapters how to find the equation of a straight line passing through a given point and having the director coefficient. So, f of x is equal to minus x plus 3. Table of variation of the affine function. Consider a affine function defined on R by f of x equal ax plus b. If a is positive, then f is strictly increasing on R since a is the slope, and when the slope is positive, this means that the line is moving upward. So the function is increasing, and if a is negative, the line is moving downward, so f is strictly decreasing on R, and if a is equal to 0, then the line is a horizontal line of equation y equal k, and the function is a constant function on R. So the table of variations of f depends on the sign of a, as shown in the following. If a is positive, the function is increasing, and if a is negative, the function is decreasing. Example 2. Set up the table of variation of the function g defined on R by g of x equal minus 2x plus 1. So as we know, we have to look for the sign of a. Since a is negative, then g is strictly decreasing on R, and this is the table of variation of g. Application 2. Please stop the video and try to solve the application. Graphical representation of an affine function. It's the graphical representation of a straight line. So how to represent graphically an affine function? Consider the affine function f of x equal ax plus b and the line D of equation y equal ax plus b that represents f in an orthonormal system. We have to remember that the intersection between the line D and the y-axis is the point 0b, and the intersection between the line D and the x-axis is the point P of coordinates minus b over a, 0. In the cases where a is different from 0 and b is different from 0. So simply we place the points a and b and join them by the straight line D. Example 3. Representing graphically the affine function f of x equal to x plus 4 in a coordinate system. So the solution is, the first point is a0, 4 and the second point is b minus 2, 0. We place the points and we join them. Particular cases of an affine function. Consider the affine function f of x equal ax plus b. And let D be the line that represents f in an orthonormal system. If a is equal to 0 and b is different from 0, then f is a constant function. D is parallel to the x-axis, and it passes through the point of coordinates 0, b, since in this case f of x is equal to b. If a is equal to 0 and b is equal to 0, so the equation of the straight line is y equals 0, which is the equation of the x-axis. If a is different from 0 and b is equal to 0, so the equation of the straight line is of the form y equal ax, then the line D passes through the origin O and the point C, 1a. Now, the standard functions. Let's start by the function f of x equal absolute value of x. First, the domain of definition of this function is R. F is even on R since the absolute value of minus x is equal to the absolute value of x. If x belongs to minus infinity 0, then the absolute value of x is minus x. Hence, f is decreasing on minus infinity 0. Why? Because minus x, so the slope is minus 1. It's negative, so the straight line is decreasing. And if x belongs to 0 plus infinity, then f of x is equal to x. Hence, f is increasing on 0 plus infinity. The table of variations of absolute value of x, from minus infinity to 0, it's decreasing, and from 0 to plus infinity, it's increasing. And the absolute value of 0 is equal to 0. So this function admits a minimum which is equal to 0. Now the graphical representation of this function, this is the table of variations. And from this table we can conclude that f is decreasing on minus infinity 0 and increasing on 0 plus infinity, and has O 0, 0 as an absolute minimum. And we have the following particular points belonging to the curve C. So if we draw the curve, it has a V shape. And notice we have a straight line here, a straight line here, because f of x is equal to minus x when x is negative and x when x is positive. We have here two affine functions. Now, the standard function f of x equal radical x. The domain of definition of f is 0 plus infinity, since we have a radical here and we can't put a negative value under the radical. F is strictly increasing on 0 plus infinity. The table of variations of f of x is, for x going from 0 to plus infinity, f of x is increasing from 0 to plus infinity. Now, to represent radical of x graphically, we take the table of particular points to adjust the curve, and we draw the curve. This is the curve of radical of x. We have the points 0, 0, 1, 1, 4, 2, and 9, 3 belonging to the curve. Standard function f of x equal 1 over x. The domain of definition of this function is r star. X could be any number except 0. And f is odd on r star. F is strictly decreasing on its domain of definition. The table of variations of f of x is then, this is the table of variations. It's defined from minus infinity to 0, union 0 plus infinity. We can't take 0. It's decreasing over its domain of definition. How to represent graphically the function f of x equals 1 over x? Remark, the domain of definition of f is minus infinity 0 union 0 plus infinity. So the representative curve C of f is formed of two pieces. each piece represents one interval. One of them is to the left of the straight line d x equals 0, and the other is to the right of d. So this is the table of particular points to adjust the curve C, and this is the curve C. So as you see, we have two pieces. One piece is to the left of the straight line d of equation x equals 0, and the other piece is to the right of the straight line, and these are the points forming the curve. The standard function f of x equals x squared. This function is defined on R, and it's even on R. F is decreasing on minus infinity 0 and increasing on 0 plus infinity. So to draw the table of variations of x squared, we have from minus infinity to 0, f is decreasing, and from 0 to plus infinity, f is increasing. Now we have to draw the curve representing x squared. We know that this curve admits an absolute minimum at the point O, 0, 0. These are some particular points belonging to the curve, and this is the curve representing f of x equal x squared. This is the assignment for next time. Thank you.